Hello, good morning. This is lecture two of week five of our course BPSC 031 Spring Wildflowers. Last Monday, we saw there wasn't a recorded lecture because we had a course review um, for the midterm exam, which will be on Friday, the 1st of May. So this is going to be the first and only lecture of recorded lecture of week five, second lecture of week five. Today we're going to see the four-parted families. The four-parted families are a group of families with fairly similar flowers, although they're quite easy to distinguish in the field. And they all have four petals, and the petals are not fused. They are separated. They are detached from each other. The plants are apopetalous, and they're very common in the California wildflower flora. So let me start with a slide projection, and we can see a little bit of the traits of the three main families with four-parted flowers in the California wildflower flora. So the four-parted families are is a family that has perfect flowers. Perfect, remember, means hermaphroditic, both sexes in a flower. And the corolla is usually of four petals. It's usually composed by four petals. And it composes three very important families: the Brassicaceae, or the mustard family, the Onagraceae, the evening primrose family, and the Papaveraceae, the poppy family. Let's go to the first family, the Brassicaceae. The Brassicaceae are quite easy to identify. They have four petals arranged at right angles. They look pretty much, if you look at them from above, they look like a square cross. Hence the name also for the family. The family had an ancient name, Cruciferae, or also the cruciferous plants, because the flowers look like a cross. They have 6 stamens, of which 4 are long and 2 stamens are short. And we'll discuss in a little while the role that the short stamens has. And the fruit is a silique, that is formed by 2 carpels joined together with parietal placentation. The plants have a characteristic pungency. They have a sharp smell that you will recognize immediately. It's the smell of cabbage when you cook it, the smell of cauliflower when you cook it, or the pungent taste of wasabi or horseradish or watercress. All plants in the family, if you chew the leaves, will be somewhat spicy, somewhat pungent or piquant, as they also call them. They're mostly herbaceous plants with pinnately dissected leaves that, of course, when crushed, release a pleasant piquant odor and possess a mustardy flavor. They all taste a little bit like mustard. The reproductive morphology, we mentioned it already. The flowers are often arranged in racemes that keep growing and producing new flowers as the older ones ripen and yield fruit. The flower has 4 sepals, 4 cross-like petals, 6 tetradynamous stamens. The word tetradynamous means 4 long, tetra, and 2 short, dynamos, and a superior 2-carpal ovary with parietal placentation. The fruits are siliques, or sometimes, if they're not long, if they're rounded, we call them silicles. So this is an illustration of Brassica nigra, the black mustard, in which you can see the flowers. They normally occur in long stems, like racemes, long stems, in which, if you look at the older flowers, they have already fertilized and are forming a silique, and the younger flowers are open and receptive to pollinators. In the middle, you might find a wilting flower. If you look at the flower, it has 4 petals that form, looks from above, a cross-like structure, hence the name cruciferate. And the ovary is superior with multiple ovules that eventually form multiple seeds. Some of them, like for example, the canola, you will see them in cultivation in big fields. The seeds are used for oil. Flowers form racemes, with the older flowers forming already a silique. And here is again another illustration of the cross-section of a flower. Again, it's 4 petals forming a cross, 4 long stamens, 2 short stamens, and a superior ovary with a multiplicity of ovules. Some plants that are common in the California flora are the Cardamine bulbosa, the bittercress, Lepidium campestre, the peppergrass. Look at the peppergrass, how the silique looks round, right? This is a silicle. Instead of being elongated, they turn into a round structure when they become fertilized. And you can see here the difference between the silique and the silicle. Now, a little interesting anecdotal thing, the Brassicaceae smell have a typical horseradish type of smell because of the presence of a substance called glucosinolates or mustard oils. And there's a family, there's not a single one. You can see the molecules down here. And this R means a long carbon chain, and according to how long the chain is, the flavor of the glucosinolate can be different from very pungent, as in wasabi, to only mildly piquant, as in other plants. Also look at the sulfur structure here, and we'll talk about that in a second. Glucosinolates are toxic to insects. And so most insects will avoid eating cruciferous Brassicaceae because they're toxic for them. And that's why they are, by and large, such incredibly successful invasive plants. The California flora is completely invaded by European Brassicaceae, especially the wild radish, Raphanus, and the wild mustard, Brassica campestris. Now, there's a group of butterflies known as the cabbage butterflies in the genus Pieris that actually have developed through centuries or millennia of evolution or coevolution with the plant the ability to survive the toxic glucosinolates, and they accumulate them in their body. So much so that they become toxic themselves. They accumulate large oil glands in their body full of cabbage or cauliflower or any other Brassicaceae glucosinolates. And if a bird dares eat them, it will get intoxicated by the sheer concentration of glucosinolates. Now, glucosinolates, although they're toxic to most insects with the exception of the Pieris butterfly, they're not toxic to humans. But they give the plant that characteristic tangy or piquant taste that most of us appreciate in mustard, for example, in cress, or in wasabi. Another very interesting trait in the Brassicaceae is the fact that from the original wild mustard, Brassica campestris, dozens of different varieties of plants have been domesticated. Brassica campestris being selected for the rosette has given us cabbage. This selection occurred mostly in Northern Europe, what is now Germany and Alsace and Belgium. The farmers have been selecting the wild cabbage for the rosette at the base that forms in winter, and or wild mustard, sorry, and we have cabbage. As the name Brussels suggests, in Belgium, some farmers for centuries have selected the stem, the plant that produces the stem, and has large axillary buds, like we can see here in the leaves. We have a node, an internode. In the nodes, has an axillary bud. They have selected stems with enlarged axillary buds, and those are the Brussels sprouts. Other farmers have selected for dense heads of flowers. So instead of having a typical sort of fairly open raceme, the plant has developed very, very dense corymbs of flowers, and we have the cauliflower. Another variant selected in other parts of the world of the same density of flowers has given us the broccoli. In other parts of the world, they have selected, especially in Eastern Europe, the root at the base, the base of the base of the stem, and the beginning of the pivot root, and they have given us this tuber that is kohlrabi. And in Asia, mostly, they have selected the leaves again, like the cabbage, for more open leaves, and we have kale. And this is just the beginning. The wild mustard has been selected over and over and over again by different farmers in different parts of the world to produce all sorts of things. Even sometimes some springs, when you get lots of wild mustard coming up in Riverside, I'll go out and collect them in box springs, for example, where you get dense formations of wild mustard. And you can chop the inflorescence and the upper leaves that are very tender and cook them, and they're really, really nice to eat. So it's a plant that has accompanied humans for centuries and has developed all sorts of different forms under cultivation, which is quite amazing. And it's a demonstration of natural selection. Here you have the same type of illustration with photographs, cabbage, Brussels sprouts, kale, collard greens, calabrese, broccoli, cauliflower, and kohlrabi, among others. For example, the Chinese broccoli, which is almost like, it's thinner, it's like an asparagus. It's also part of this plant family, of this plant species, an amazing species. Other plants in the family are the radish, the Raphanus sativus, the bok choy, Brassica rapa, which is very related to the cabbage plant, Brassica campestris, the rutabaga, which is very similar to the kohlrabi, the horseradish that belongs in a genus of its own, Armoraceae, the turnip, that comes as another variation of Brassica campestris, the Chinese cabbage, and of course, a plant that many of us love. I love Asian food, especially Japanese sushi with wasabi. Wasabi comes from a plant known as Eutrema wasabi, which belongs in this family, and a concentrate from the root is produced, and that's what we add to a lot of dishes in Japanese cuisine. Mustard comes from this family. All mustards come from this family, but they can be made from a pile of different species, like Brassica nigra, Brassica juncea, Sinapis alba. There's almost no plant in the Brassicaceae of which the seeds cannot be ground into mustard. All the seeds have high concentrations of glucosinolates, and if ground into mustard, they will give a really nice piquant taste, tangy taste to the ground paste. Some California genera, the Raphanus sativus, the wild radish, it's all over the place, fairly invasive. It's not native. Brassica nigra, the wild mustard, very, very invasive in our hillsides and chaparral in California. It's not a welcome visitor from Europe. The Cicimbrium altissimum, the tumbleweed, invasive in our deserts. A beautiful plant in the few water ditches that we still preserve near Riverside. There is this reserved Sycamore Canyon that has a little arroyo, a creek that has a lot of watercress, Roripa nasturtium aquaticum. It's really nice to eat in salad. And Pincus plume, Stanleya pinnata, common in chaparral. This is a California native and worthy of conservation. It's fairly threatened by disappearance of native vegetation. Now we'll go to the four-parted families. Sorry, we'll still keep in the four-parted families. We'll go to the second family of the four-parted families, the Onagraceae. The Onagraceae, the way to tell them, they look pretty much like the poppies, but their ovary is inferior. So I will sort of dispel with all the reading of the species. You can do it from the lecture notes, but this is a typical illustration of Enothera californica, California's evening primrose. The plant has an inferior ovary. You can see here, this part here is the ovary. Then it has a long and elongated projection of the receptacle that forms a structure known as a hypantium or hypantium. And then it has the sepals, the petals, and the stamens. There's a multiplicity of stamens. The carpels are 4, and you can tell that the carpels are 4 apart from looking at the fruit, that is a capsule, by also looking at the number of stigmas. It has 4 stigmas, a cross-like formation of stigmas. Some species of the family is, for example, the fuchsias. You can see it here quite well. In the fuchsias, the 4 sepals are not green like most sepals, but are vividly red. And then the 4 petals follow together with the stamens. You can see this part here is the hypantium, the receptacle, the enlarged receptacle, and the ovary is way below down there. You can see here a cut of the fuchsia flower. You can see the inferior ovary with a multiplicity of ovules with central placentation. You can see, it's axile placentation really, central axile placentation. You can see here the nectar glands that attract the insects, in this case mostly moths and hummingbirds. And then you can see the hypantium and the flower parts well above the ovary attached to the hypantium. This is more near to Southern California, Enothera californica, where you can see the same structure. The ovary is well below. From it, you get a hypantium coming up. You can see the hypantium here, and the flower parts are on top. Some California genera, Enothera californica, California's evening primrose. Possibly during the live lecture, we're going to do a dissection of one of them. It's a really beautiful plant. And the Camisonias, the genus Camisonia, the suncups, has a pile of species in our native ecosystems, in our chaparral and coastal sage scrub, known as suncups, the commonest one around Riverside and that area of the Inland Empire is Camisonia bistora. In the mountains, not so much in the chaparral, already in the conifer forest in the mountains, you have these species known as Clarkias. They're really very pretty, normally red or very deep pinkish red with very nice flowers. They're really, really attractive, beautiful flowers. And now we go to the last family, the Papaveraceae. The Papaveraceae is a poppy family. One of the traits of poppies is, of course, the ovary is superior, as in the Brassicaceae. The main difference between the poppies and the evening primroses is that in the poppies, the ovary is superior. The evening primroses have a hypantium and the ovary is inferior. The flowers are mostly solitary. They don't form dense racemes like the Brassicaceae do, with a saucer-shaped corolla. Normally they have normally they have 4 petals, and in some species, like in the Mittelija poppy, they have 6 petals. And the number of sepals is half the number of petals. So the plants with 4 petals have 2 sepals. The plants with 6 petals have 3 sepals. The sepals, one of the traits of the Papaveraceae is that the sepals are caducous. They fall when the flower opens. So if you look at a flower that is open, you will not see the sepals in the calyx, and that's a very interesting telltale sign of the family Papaveraceae. Here you have an illustration of the California poppy. You can see here a bud before opening, um, and the sepals are covering the petals. You can see it here, the sepals are starting to fall. One sepal has fallen, another one is still there. And you can see here the flower already, both sepals have fallen and the petals are open. It has, like all the Papaveraceae, have a multiplicity of stamens. Botanists will use the symbol infinite to indicate that the number of stamens is too large to count. They have a very, very large number of stamens. The flowers in almost all the Papaveraceae are pinnatifid. They are very, very strongly podded and divided almost like they were pinnate. Some important plants, although not native to California, is the oriental poppy, Papaver orientale. You can see here the caducous sepals, the sepals that are that fall, and the petals opening. In the oriental poppy, in all poppies, the fruit is a capsule. In the genus Papaver, like the oriental poppy, the capsule has a series of pores, of slots in the upper part of the capsule. If you look at the fruit before it turns into a capsule, you see the ovary. This is the ovary once it's ripened. And you see it has the stigmas form like a very pretty radiation around the upper part of the ovary. They don't have a style. The stigmas are sitting on the ovary. And by counting the stigmas, you can get a very good idea of the number of carpels that form the plant. For example, this one is 1, 2, 3, 6, 9, 10, 11, 12, 13, 14, 15 carpels form this ovary, and you can see the multitude of stamens. The oriental poppy is used for a number of things. It's especially used in Central Europe for cooking. The seeds are really an important part of European culinary tradition, like poppy seed cookies and all sorts of poppy seed cakes. And of course, also the poppy seed has a trait that all the family has, but the poppy seed is really well marked. Within the genus Papaver, one species, Papaver somniferum, has a large amount of latex. All the plants in the Papaveraceae have latex. Latex is a substance, you will see in the lecture notes a good description of what latex is, but it's a substance that runs in ducts inside the plant. And it's like a healing substance. If a plant is damaged, the latex will be exuded as like a milky substance and heal the damage. And also the latex is quite toxic to animals. So if an insect starts eating the plant, it will get a mouthful of latex that will probably kill him. And the latex will become like the cicatrizing agent, like the scar forming agent, the healing agent that stops the damage in the plant. Now humans have learned for centuries, if not millennia, that if they cut the fruit while forming, the capsule is still in this green state, it will start exuding latex, and you can collect that latex with a sharp knife or with a razor, and you can use it for a number of things. This latex is known as raw opium, and it's formed by a combination of different substances that are very strongly psychotropic. Those substances can be later, once you collect a lot of raw opium, they can be processed in the lab and separated into morphine, distilled or purified opium, and a number of other products that are used in medicine, and of course they're also used as drugs by human populations. Some important plants is Sanguinaria canadensis, the bloodroot, that has these stems at the ground level that will exude a pinkish latex, hence the name bloodroot if you cut it. Um, you will see in the lecture notes a little uh, square, a little a note on the called Darwin the Drugstore, which is the natural history of latex and poppies. I recommend that you read it. It will explain what latex is, but latex is endowed with toxins, and it is really extremely poisonous. The latex is evolved naturally as an anti-herbivore agent to prevent herbivores from eating it. But of course, humans, we have been clever enough to learn how to dilute latex or the opium in poppy latex and have it for medical effects. Like most ethnobotanical uses of plants or traditional medicine uses of plants consist in using alkaloids, toxic substances, in a perfect dose or in a dose that is good enough to be able to cure some diseases without killing us. Some California genera are Argemone munita, the prickly poppy. Unfortunately, we won't see it. It's very common in Swarthmore Canyon in our second field trip. Argemone is beautiful. It has 6 petals, as you can see here, with a crown of yellow stamens, and you can see the capsule. It's called prickly poppy because the plant itself and the capsules in particular are full of prickles or spines. Dendromicon rigida, very common in chaparral around the riverside. The tree poppy looks very much like a California poppy, but instead of being an annual, it's a perennial. It's a little shrub. Eschscholzia californica, this is the symbol of the state. Some researchers believe that the name the Golden State comes from these type of landscapes that were observed by the first non-native colonizers, the first Europeans that arrived to California, both Franciscan priests from Mexico and colonizers that came from the east in the United States. And when they saw in spring these beautiful golden fields, some people believe that that's the reason why California became known as the Golden State. And finally, Romneya coulteri, Coulter's Metelicha poppy or Matelicha poppy, which is a shrub also very similar to the prickly poppy, but it's a very tallish. It can be 6 feet high. It's a shrub with beautiful flowers. So I'll stop sharing now. This is the end of this presentation. Thank you very much for your attention. Please read the notes. And of course, I do hope to see you in class because we're going to do some dissections of flowers and see them in the microscope. Next Friday, the 1st of May, we won't be having any lecture because it's going to be the midterm exam. So I hope to see you there. I'll open the Zoom connection system, the Zoom conferencing system, and in order to give you, to pass to all of you the link for the midterm exam. And we will do the midterm exam between 9 and 10 on Friday, the 1st of May. I really do wish you the best. I was going to say the best of luck. I hope it's not luck. I hope it's just doing well. I wish that you do very well. I would like to see you doing very well. You know, it's hard in the middle of this pandemic to teach and to learn without actually being in proximity with each other. But some of the things I'm seeing that you guys are doing are amazing. And I hope that you really make me proud in that midterm exam. Thank you very much. This is the end of this lecture.